So in this investigation about the formula for the surface area of a regular pyramid, in this shortcut, right, is what we're looking for. We're going to be looking at this net here. And we're going to start with just trying to figure out the lateral area. And so our first instruction is, since we are only working with regular pyramids where all sides are equal, remember that's what the word regular means, all sides equal, or congruent technically. Let's call each side of our hexagon, and this we're going to start with a hexagonal pyramid. Label S on each side of your hexagon. What letter could you use to represent the bottom of each triangle? So if each side of our hexagon is S, and we know that that matches up with the base of our triangle, we know that all of the bases of our triangles will also be S. It's the same S because we know that, like, for example, this S would match up with this S when I rolled those triangles back around the hexagon and fit them back together to make the whole pyramid, right? So this is the rollout method in which I've created a net. Let me go back just a step. This is the net of the pyramid, the net of the sky, right? And so using the rollout method, these are the same picture, just two different depictions, 3D and flat 2D. What kind of height is represented on each altitude, the perpendicular segment on each triangle? Label each altitude on your triangles with an L or an H depending on your answer. So we're talking about these altitudes here. Are those the height going up the middle of the pyramid, or are these the slant height on the sides of the pyramid? So remember, when you roll these back around, when you fold this net back together, what we're looking at is these guys. It's the ones that are on the side, the ones that are slanty up from that vertex down to the base, perpendicular, right? And so these would all be slant heights, I hope is what you were thinking. Okay, so our next step, write a conjecture for the formula for lateral area of a pyramid. Use S and L in your formula. So it looks to me, so remember, lateral area is just the area of the sides. We don't include the base. So we're just looking at how much would all of these triangles be together. And I hope you'll bear with me. I'm aware we could just do 6 times L times S, 1/2 L times S. But we know a triangle is 1/2 base times height, right? In this case, our base is S and our height of each triangle is L. So we're looking at 1/2 times S times L for each triangle, right? And now we have 6 of these suckers. So our lateral area, our area of just the green triangles, not including the hexagonal base, right, would be 1/2 S times L 6 times. So 1, 2, 3, 4, 5, 6. So the reason why I wrote it out longhand like that is because I can do some magic here. If I undistribute the 1/2 and the L, if I take that out of each of these 6 terms, what I would have left is 1, 2, 3, 4, 5, 6 S's, right? So if I were to do this, I'm reverse distributing 1, 2, 3, 4, 5, 6, right? If I were to distribute this back out, I would get this line up here, right? So now what we're going to do is, let's think about this. Looking at our picture, what is all of these S's added up? Isn't that the distance around our hexagon? Isn't this the perimeter of our hexagonal base? And so that, my friends, is the shortcut for lateral area. We're going to call it 1/2 times the slant height, that's what the L was, right, times perimeter. So that's what goes here. So you can also call it 1/2 A lot of times you'll see it written as P times little l, big P representing perimeter, little l representing slant height. And then the only difference between that and surface area is this includes the base, right? And so we're just going to write this as 1/2 times perimeter. Remember, order doesn't matter in multiplication. It's commutative, so I can say perimeter first and slant height second if I want to, plus area of the base. Or, that's all written out in words, or that's equal to 1/2 P times L plus big B.